Today we're going to be demonstrating the freefall and gravitational acceleration simulation. I'm here in Connect, having clicked Add Assignment, and I'll now click the eyeball on the sim in question so that we can preview it. Every simulation starts with an introductory slide. It includes background material and key concepts, learning outcomes in overview, and then important information in before you begin that the student will probably need over the course of the simulation. You can see in the upper left that introduction and lab simulation are two tabs that the students can click back and forth between throughout the simulation itself. I'll proceed by clicking on the Continue to Laboratory Simulation button on the bottom right. We have keyboard shortcuts in instructor view so that if you want to preview the lab without actually doing the lab, you can do that. You can skip through the phases. You can also see, and students can as well, all of the steps for each of the phases by clicking on Methods in the toolbar on the bottom of the screen. Within each individual phase, the phase title and the steps for the phase are detailed on the right. So you can see when I do the view video of apple dropping into the bowl, I'll click play on the video here. Notice that number 1 doesn't check off. So the steps are available as they would be if you gave students a lab manual in a live lab, but their hand isn't being held throughout. We'll click continue and answer this pop-up question, making sure that we understand why we're doing what we're doing and where the data actually needs to be collected. So we're being asked in step 2 to calculate the duration of one video frame in seconds and then record it in the lab data. Again, as you would if it were an in-person lab, students have a data sheet here. They're being asked to do some calculations, and I'll just fill that in for now. Now, if we make an error in our calculation, say 1.67 seconds, we do get an alert letting us know that that's not correct. So we'll go back and change that data. Okay, we think that we've completed steps 1 and 2. Let's click Go to Phase, and it does show that we completed both steps, moves us on to the next phase. We're now going to calculate the width of the bowl in centimeters against pixels. We've clicked the left and the right rim of the bowl, and we see that that's 283 pixels across. We're asked to calculate the length of a pixel, and we'll enter that here in lab data. Okay, we now want to collect the data that's actually while the apple is falling, now that we've calibrated a little bit to the pixels and the frames per second. So we'll click near the apple stem. Notice that I don't have to click exactly where the stem is. There's a little bit of leeway there, and it does want me to record the frame number and the Y coordinate, the frames to time. So just continuing to do those calculations, continuing to enter that data in pixels and in centimeters, as well as the time from the frames. So we have all of that in front of us, making sure that we can do that math. We're going to get that next piece of data. Again, fill it in. And this time, now that we have 2 data points, checking the velocity in centimeters per second. I click Go to Phase. Now that we collected a couple of those data points manually, the system in phase 4 will auto-populate additional data just so that it doesn't get too tedious, and we can focus on what's really important here, which is making sure that we can collect the data and taking a look at interpreting that data and graphing it, which we'll do soon. Okay, there we go. We have a complete data sheet. We can close our lab data. That'll save when we go to the next phase, and we can go to phase 5. This simulation has 2 phases that involve graphing. We can see from the title that phase 5 is asking the student to graph vertical position coordinate versus time. This pop-up question asks students to think about the raw data that they've collected and make a prediction about what the graph is going to show. So let's make our selection and click submit, and we can continue on to the graph. It looks like we might have made a mistake in selecting our dependent and independent variables. So let's take a look at time and position flipped. And we get that sort of over-the-shoulder feedback that you might give a student in a live lab. You see that scatter plot does indeed have a parabola opening down type of shape, and we want to click Save as indicated in step 5 to make sure that this graph is included in the lab report at the end of the simulation. When we enter our second graphing phase, we notice that the title is Graph Vertical Velocity versus Time. So again, we want time for our independent variable and vertical velocity, that calculated vertical velocity, as our dependent variable. Once again, we'll take a look at a scatter plot. And in this case, in order to have the students make a little bit more sense of the data, we want to display the regression, noticing that we have a line with negative slope. Let's open the lab data, enter that slope, and then also determine the magnitude of gravitational acceleration. Now, if we are asked to do these calculations and we're really not sure what to do, there are two ways that we can look up the information as a student. One is the hyperlink down at the bottom of the pop-up box that pops up all of that equation information that we need to make the calculations that we're being asked. And the second way would be to go back to that introduction slide, take a look at the information that we were given in before you begin, and hop back in here into the simulation to make that happen. We don't lose any progress when we do that because student progress is saved as each phase is completed. We saved that graph, we did our calculations, so we should be able to continue on to that last phase, which is really just the save lab data phase. You can see all of the data that we manually calculated, the data that was auto-populated. As we scroll down, we see those final calculations that we made and the graphs that we populated. So if you want to have a student copy and export this data to Excel for additional analysis, or simply print to PDF their lab data and submit it to you with or without additional analyses, that's easy to have, easy to ask them to do. Notice with this big yellow ribbon, congratulations, your lab has been finished and submitted. And so that's really it. Thank you for following along with this demonstration of free fall and gravitational acceleration.